Hey guys, today we're going to show you some neat things you can do with the Raspberry Pi Pico. So here we have a Raspberry Pi Pico, no pin solder or anything yet. We're going to do a basic demo. First we're going to plug it in, and then we're going to show you how you can install MicroPython. So over here we have the Thonny IDE, and from here we're going to install MicroPython. So just click on MicroPython from that little thing at the bottom. Say install. Now to get to this point where you can install it, you might have had to hold the boot select button on your Pi while you hold the button down, plug the Pi in, and let it boot up. So it's going to be in this mode where you can install MicroPython. I didn't actually have to do it. It allowed me to install MicroPython without holding the button down for some reason. But you're supposed to have to hold the button down. Try it both ways if one way does not work for you. Now here I'm using the shell where you can directly run Python commands on your, in here I'm running print hello world. There's your basic hello world program. You can basically run Python commands in an interpreter right here. So you have this Python shell that you can run commands from. So here I just ran a little snippet of code that will make it makes a LED blink. Now I used pin 25 and you can see right there it actually doesn't blink. It actually just at this step I'm just turning the LED on, and that one counts as pin 25. It's not one of the actual pins. It actually refers to that LED. So yeah, that's pretty much it for that. Now I hit enter, and off screen I actually disabled that LED, so I turned it off. And cut away here. You can see I've set the value to 1010 a few times in my history in the shell here. So you could actually save a program in that pane up top, or if you just want to test things, you can type out your commands in the shell here. Now you see here I have some actual code, and I want to save it to the Raspberry Pi. So I'm going to do that, and I'm going to run the code that was actually saved. I'm going to call it blink.py. So there we go. And you notice this code, I created a timer, and I'm having the timer call my function called LED blink. So every so often, every time the timer goes off, it's going to call that function and tell the LED to go on or off. And there we see the LED is actually blinking. Now so far this is pretty boring. It's just the onboard LED. Now, here we go. Now you'll notice this is on a breadboard. It's using the same code, except I changed the pin, I believe, to pin 15. Just check the link in the description if you want the actual code for this. So we're going to cut over to the code in a second right here. So there we go. So this is what the actual code looks like, and you'll notice this is pretty much the same thing we saw before. Only thing different is pin 15 is set, and also the frequency is set to 2.5 here. I think I actually had it set to 5 before, and I think the speed that it was blinking at in the clip before is set to frequency 5 as well. So you can change that to whatever you like. The other thing I wanted to point out is that this actual code snippet here only toggles the external LED, and in the example I was toggling both of them. So I was actually running code. I basically just put both of the, I created a variable for each of the LEDs, and just I created LED 1 and LED 2, and I put those in the blink function and toggled both of them. Instead of just having one LED variable there, I created two of them and had them both toggle when the blink function was called. So if you want to check the link in the description, I'm probably going to throw an example. I'm going to have that example in there too, so just check the link in the description of this video. And I'd like to point out, I'd like to just talk a little bit about what this is doing here. So this line at the bottom is creating a timer, initializing it, sets the frequency and that it's going to be periodic and stuff like that, and it sets a callback function. The callback function, it says, is going to be blink, and that's the function that we defined above that up there on the line that says def blink, and we pass the timer to it. So and that all that does is toggle the LED. So basically every time the timer is fired, it just toggles LED on and off. Other than that, we just defined some variables and imported some things. That's about it for that code snippet. So let's cut back. Yep. So if you wanted to see pictures of this or anything like that, again, just check the link in the description. So if you don't want to have to pause this video, or you want to see something with at a higher resolution or whatever, just check that out. So here we see some slight modifications I made to the circuit. There's a button added here. So we press the button and it starts toggling back and forth in a loop. As long as we hold it down, now we let go and it stays at wherever it left off. So as long as we're pushing the button, it's going to toggle back and forth. Every time, if we just press the button quickly once, it's going to toggle it one way or the other. If we hold it down, it toggles back and forth. If we let go, it just stays there. So anyways, here's the code that will actually let you use the button here. So you can see we just import the normal stuff that we do normally import. We set the LED like we did before, create a variable for that, set the pin that we're going to output to, and we are going to also define a button variable. That's going to be on pin 14. If you looked at the picture before, that went to pin 14. So we also have a while loop, an infinite loop, and the first thing we do in that loop is say if button value. Now, so if the value is true, it's going to run the stuff in that loop, meaning if the button is pushed, it's going to toggle it on or off. So if the button's not being pushed and it's off, it's going to stay off. If the button's not being pushed and it's on, it's going to stay on. If the button is being pushed for each run through, each time it loops through here, if the button is being pushed down, it's going to toggle, it's going to blink back and forth. So, if you let go of the button when it's when the LED is on, it's going to stay on. If you let go of it when it's off, it's going to stay off. But yeah, as long as you're holding the button down, it's going to toggle on and off like you saw. So, I set the sleep time to, half a second here, and that's about all there is to the code. That's relatively simple. Now, here we have another example. Basically, you notice here the LEDs are actually slowly, actually not that slowly, but they slowly increase and decrease in brightness. So this is using the pulse width modulation module from the API, and we're going to cut away to the code to that and show you how that works in just a second here. Alright, so basically this is the code, and basically we are going to be importing a few things at the top here. So pin like we did before, but also PWM, the pulse width modulation module, and we're also importing sleep from time. And now we're going to create a variable called PWM, and we're going to call PWM and pass pin 15 to it. So we're going to be controlling pin 15 with PWM. So we've created that object, and we're going to set the frequency to 1000 on that. And then we're going to have an infinite loop here. So we have a while loop that just loops while true, and we have 2 for loops within that. Now the first for loop is going to loop over a range going up to 65,025, and it is going to basically sets the PWM duty. So the range goes through each one of those numbers and just slowly changes the actual brightness. So the setting PWM duty is going to change the brightness, so that you pass a slightly different value to that each time through the loop. And then in the next for loop, you do, it's the same thing except you're going the other direction. Instead of going up to that value, you have a range that goes down to that value. And so we're basically counting backwards. So the first for loop, it's getting brighter, and then the second one, it's getting it's getting dimmer, right? So it sleeps for like a small fraction of the second on each pass through both of those loops. So it's like a continuously getting brighter and then continuously getting dimmer. And then each of these loops just gets repeated over and over again. So brighter, dimmer, basically for infinity. It just keeps on going infinitely. So that's basically how the code works, if that makes sense how I described that. But basically copy paste this in there and connect the pins the way I did, and you're going to get the result that I showed you. Now you don't really need the button to be attached for this, like you saw in the example before. The button, I just had the button on there from the previous example, but I wasn't actually using it, so you don't need the button for this to work. So that's pretty much it for this one. On to the next example. And so here in the final example, we have a potentiometer attached to this going to yet another pin. And this basically just gives us the ability to, we can turn it one way or the other to control the brightness, which is a pretty neat ability. And we're going to show you the code for that in just a minute. But yeah, this is the most elaborate demo we're going to do in this video. So yeah, just a neat thing to look at here. On and off, nothing too crazy. Now here we see the code for this. We're importing a few more things. So we have pin, PWM, and ADC. So PWM is for pulse width modulation, allowing you to control, how much power is going out to the LEDs, and ADC is going to give you control over, is going to allow you to work with the potentiometer. And we're basically just defining those on different pins. So pin 15 and pin 26, and PWM frequency. We set that to 1,000, and we set duty to, we're basically calling ADC read uint. So we're reading the value from ADC, which is basically taking a value from your potentiometer and assigning it to that duty variable. We then use the pulse width modulation object that we have there, and we call duty U16, and just pass that variable to us. Whatever value that we got from that potentiometer, we're going to pass that over to the pulse width modulation. Basically this API thing here, and it's going to set the value of the LED. So we're taking the value from the potentiometer and using it to set the value of the LED. That's all we're really doing there. So yeah, just make sure you do check the link in the description. I'm going to try to make sure I have pictures of this, maybe even diagrams. I'll see what I can put together. I'm going to definitely have the code snippets that you can copy and paste into your IDE and try them out on your own Raspberry Pi Pico. So check that out. Check the links in the description. Also check the link in the description for where you can pick up a breadboard, any of these electronic components. You also might want to check out my other video where I show you how I actually soldered these together, or how I soldered the pins on the Raspberry Pi Pico so that I could connect it to a breadboard. Also, if you want to know where to pick up the Pico, you can get this all on Amazon. I'm going to have links to where you can pick this up on Amazon. Check the links in the description. And that's it for that. Go ahead and hit that like button. Also hit the subscribe button. You're not going to want to miss out on our other great videos. We have a lot of great stuff we put out already, and we have a lot of stuff coming up soon. So definitely hit the subscribe button, and also hit the little bell icon. Otherwise, YouTube's not going to alert you when we come out with a new video, and you're not going to want to miss these. We put a lot of other great content out. This includes hardware, software, networking, servers, coding, electronics, single board computers, 3D printing, robots, and a ton more. Also, leave a comment down below, not just for me, but for the next person who watches this video. If you know something that I don't know, or you have any comments, questions, criticism, whatever you want to say, just leave the comment down below. Hopefully you found this video useful, or at least interesting. And as always, thanks for watching, and we'll see you on the next video.